In the last video, you learned how to go from a formula and then calculate the percent composition of each element. So you determine that like carbon makes up this percentage of this compound, oxygen makes up this percentage, and so forth. So you went from the formula to percentages. Now in this video, we're going to go the opposite way. Let's say discovered this new compound. You take it into your lab, you break it down and figure out the percentage of each element in that compound. Well, then you're going to want to take those percentages and convert them into a formula to figure out what the formula of your new compound is. So that's what we're going to do in this video. So the empirical formula is basically just the symbols and subscripts which show the lowest ratio of elements in a compound. Now the key to this is for empirical formulas, it says the lowest ratio. So empirical formulas are always a lowest ratio. There is another process called molecular formulas that show you the not necessarily the simplest whole number ratio, but we don't do those in this class, so we're only focused on empirical formulas. Now there's steps to follow. They seem really complicated at first, but once you do one or two problems, it's not really hard to memorize them. You do one or two and you'll just be like, okay, I got this down. So at first it might look intimidating. I'm just warning you, it's not as bad as it looks. So for the first step, you're given percentages. You just convert those percentages symbols into gram symbols. If you're already given grams, you just skip the first step. So you assume a 100 gram sample and you just convert the percentages to grams. We'll show you examples later. So again, if you start with grams, you skip this step. Then, after you have grams, then you convert those grams into moles. You're going to have to divide by the molar mass of each element, and this seems like a lot of work, but it's not as bad as you think because each of the things you're working with are elements. So it's not like you have to add up the molar masses, you just have to look up that element's molar mass on the periodic table. Now number 3, you divide the moles by the lowest number to find the smallest whole number ratio. That molar mass shouldn't be there. Somehow I think when I copied and pasted that down, that snuck in. Number 4, give compound with whole numbers, so multiply accordingly, and then write the formula. So here's how you multiply accordingly. I'll pull this back up when we actually use it, so it'll make sense then. Just write this down for now in your notes, and then I'll do an example. So here's the example. I think after you get those steps written down, you'll probably follow those steps for the first maybe 1, 2, maybe 3 times you do this on your own. And then after that, you'll probably just put the steps aside and you'll just know how to do it. Because once you do it a few times, you just remember the process pretty quickly. So here's how you start. You're given percentages. You've got potassium, chromium, and oxygen in this compound. And it tells you what percentage each element is in this compound. Now step number 1 says convert those percentages into grams. So we've got percentages and we convert them to grams. We don't do anything special. We assume a 100 gram sample. So if I had a 100 gram sample of this compound, if potassium makes up 26.56% in a 100 gram sample, that would equate to 26.56 grams of potassium. Same thing, just converting the percents to grams. Nothing special there. Again, if you're given grams, just skip this step. Step number 2, convert the grams to moles. So you take each of these gram numbers and convert them to moles. So what you're going to do is you're going to start a ladder with each of those numbers. So you just take each of those grams, set up a ladder. Now we'll solve the mole conversion here. Again, you take grams of potassium, bring it down. You take this unit. Same thing, grams of chromium, bring it down. Grams of oxygen, bring it down. Now we want to convert to moles, so then I go moles of potassium, moles of chromium, moles of oxygen. The mole always gets the 1, and 1. Let's do a better one there. Now on the bottom, how many grams of potassium are in 1 mole? This is where I was saying this isn't as bad as you think. You just look up potassium, it is 39.098. grams per 1 mole. Chromium is 51.996 grams per mole, and oxygen is 15.999 grams per mole. So it's a lot quicker because you don't have to add any molar masses up. You just take the masses from the periodic table for each element. At this point, you take the first number divided by the bottom number for each of these steps. First number divided by the bottom, and you get moles. So this is how many moles of each substance there are. And the reason we have to convert to moles is because whenever you have a formula like CaCl2, those numbers are a mole ratio. You have 1 calcium per 2 chlorines, or 1 mole of calcium per 2 chlorines. It's a counting ratio, not a mass ratio. So the formula is like here, I'll write it down here, CaCl2. This is a counting ratio, 1 of these for 2 of these. So it's a 1 to 2 ratio. That's why we have to convert to moles, because moles are also a counting number, just a bigger counting number, right? Now, step 3, you divide them all by the smallest. So you find the smallest number here. In this case, the top number is the smallest of the 3. So I divide them all by, I divide them all by the smallest one. Divide this one by the smallest one. And divide this one 0.6793. And then anytime you divide something by itself, that'll get you 1. So there's 1 mole of potassium, 1.003 moles of chromium, 3.499 moles of oxygen. So what we're basically doing is taking this ratio, which is really hard to see, and setting the lowest one equal to 1, and then all the other ones relative to that 1, right? So it takes this odd ratio and converts it into a much friendlier ratio. That's what that step does. And it doesn't matter. We divide them all by the same, so it shouldn't affect the ratio. So I took those 3 numbers we got on the last page, I brought them in here. Now, this step says multiply accordingly to get whole numbers. So if a number ends in 0.25 out of any of these, you'd multiply all of them by 4. If any of them end in 0.33, multiply by 3. If any of them end in 0.50, you multiply by 2. Now, you're like, well, none of these match those, but this essentially is 3.5, right? If I round that up, we can round a little bit at this point because your numbers aren't going to come out perfectly as whole numbers. So like 1.000 rounds obviously to 1. This also rounds to 1, and we'll round this to 3.5. So that means that I follow this thing here. Because I'd never write a formula with 3.5 oxygens in it. If you've ever seen a formula, like I said, CaCl2, it's always whole numbers. You would never see CaCl 2.5. So we got to get rid of this 0.5 by multiplying them all by 2. So I go times 2, times 2, times 2. At that point, that converts my ratio into a 2 to 2 to 7 ratio. So now I have all whole numbers, which is awesome. All whole numbers. Now I have to write my formula. And a lot of students they'll get these ratios and they say, oh, I'm done. But you got to take these ratios and make a formula. So the 3 elements that we're working with are potassium, chromium, and oxygen. So we just figured out what ratio each of these are relative to each other with these numbers. Potassium is a 2, chromium is a 2, oxygen's a 7. So I take these numbers and I put them in the formula. And this is my final answer. K2Cr2O7. I took the percentages that I got in the very beginning and converted it into a formula. So let's do one more example, and this will be it for chapter 7. So it says if 3.5 grams of iron reacts with 1.5 grams of oxygen, what is the simplest formula for this product? So I want you to remember that our ultimate goal is to figure out what is the ratio between these two. What is the whole number ratio? So when we finish, we better have a formula with that ratio. So step number 1 says convert percent to grams. Well, I'm already in grams, so I'm good there. So what I'm going to do is go Fe, oxygen, 3.50 grams of iron. Bring grams of iron down. Go to moles of iron. Down here, I'm going to take my oxygen, which is 1.50 grams of oxygen. Bring grams of oxygen down. Go to moles of oxygen. The mole always gets the 1. There's 15.999 grams in 1 mole of oxygen. Then for iron, 55.845. That is an 8. Now I got to do a little bit of math on my calculator because I don't have these pre-calculated for you. 3.5 divided by 55.845. And I get 0.06267. I'm just going to round out quite a bit at this point. Sig figs aren't really a big deal for this because you're eventually just rounding out to whole numbers. For the other one, 1.5 divided by 15.999. And I get 0.09376 moles. This is iron, this is oxygen. Now it's really hard to see what this ratio is, and we'd never put 0.06267 here and 0.093 here. We wouldn't do that. We got to get these into whole number ratios. So at this point I find the smaller of the two. In this case it's this one. So I divide it by itself. But if I divide this one by this number, I have to divide all of the numbers by that same one because it's a ratio. Whatever I do to one of them, I do to all of them. In this case, anything divided by itself is 1. So you've got 1 mole of iron. And then this one, when we divide, let's do that here, 0.09376 divided by 0.06267. And what I end up getting for an answer on that is 1.496 moles of oxygen. So this will round to 1. This rounds to 1.5. And again, I can't put a 1 and a 1.5 in here. I got to get them to whole number ratios. To get rid of this 0.5, I multiply accordingly, and in this case, I multiply by 2. And again, if let's say this ended at 1.33, then I'd have to multiply them both by 3. Or if it ended in 1.25, then I multiply them both by 4. But to get rid of the 0.5, I double them, so then I end up with 2 to 3 ratio. This is not my final answer. It is my final ratio. I now know that there are 2 irons for every 3 oxygens in this formula. So again, remember my final goal is to make sure I write this formula. So Fe2O3 would be my final answer. So it says, what is the simplest formula of the product? It would be Fe2O3.